So welcome to the channel. So we are discussing a question. This question was asked in a technical test for a placement in a company of electronics branch, and that company is of VLSI domain. So that is a core electronics company in VLSI domain. So this question is based on designing a circuit. So it says draw a circuit that produces output Y equal to 3 into X. So this is a multiplier circuit where X is a 2-bit input. So we have to design a circuit to produce the output Y equal to 3 times X. So we have to use only one half adder, one NOT gate and one 2 input NOR gate for designing this circuit, and we cannot use any other components. So we only have to use one half adder, one NOT gate and one 2 input NOR gate. So as you can see, X is a 2-bit input. So we have written this 2-bit inputs X1 and X2. X1 is first bit, X2 is the X2 is LSB, X1 is MSB. So they can have either 0 0 0 1, which is 1 in decimal, 1 0 which is 2 in decimal, and 1 1 which is 3 in decimal. So we have to multiply all of them by 3. So 0 0 will produce 0 only, 0 1 1 will produce 3 in decimal. Then 1 0 which is 2 will produce 6 in decimal. Then 1 1 3, so it will produce 9 in decimal. So the maximum output can be equal to 9 in decimal. So again, if we convert that 9 to binary, then we are getting 4 bits, 1 0 0 1. So we all know that to write 9 in binary we have to write as 1 0 0 1. So the output Y will be a 4-bit output. We have to understand this first of all, that the input maximum value is 1 1, and if we multiply it by 3, then we will get 9 in decimal. So 9 in decimal can be written in 4 bits, 1 0 0 1. So the output Y has to be a 4-bit value. So as you can see, this output Y has a 4-bit value. So D is LSB and A is MSB. So we are representing output Y. Y is a 4-bit and A, B, C, D are the 4 bits. So for 0, the output will be 0 because 0 multiplied by 3 is 0. Then 1 multiplied by 3 will be 3. So 3 can be written as 0, 0, 1, 1 in binary. Then 2 multiplied by 3, 6. So 6 is written as 0, 1, 1, 0 in binary. Then 3 multiplied by 3 is 9. So 1, 0, 0, 1 in binary. So D. Now we will see how to design the individual bits of the output. Output was of 4 bits. Now we will design the individual bits. So if we see here, D is simply equal to X2. X2 is 0 1 0 1. D is also equal to 0 1 0 1. Then C is equal to X1 XOR X2. So 0 0 XOR is 0, 0 1 XOR 1, 1 0, 1 XOR 0 1 and 1 XOR 1 0. So C is simply equal to X1 XOR X2. Similarly, A equal to X1 dot X2. X1 and X2. So AND operation between X1 and X2. So 0 0 0 0 1 0 1 0 0 1 1. Ending of 1 and 1 is 1. So this will be sum of half adder, this will be carry of half adder, and D equal to X2. So for D we do not need any logic gate. Simply D is equal to X2 only. Then for B is equal to X1 dot X2 bar. X1 ending with X2 bar. So using De Morgan's law, we can write it as X1 bar plus X2 whole bar. X1 dot X2 bar. If we apply De Morgan's law, we can write it as X1 bar plus X2 whole bar. So X1 and X2, these are the inputs. So first of all, we will use a half adder. The sum of half adder is equal to X1 XOR X2. That is equal to the output bit C. Then the sum of half adder is, the carry of half adder is A. So A equal to X1 dot X2. C equal to sum of half adder and A equal to carry of half adder. Then D equal to X2. So D can be as it is. Then X1 bar. So for X1 bar we will need one NOT gate. And finally, to produce X1 bar plus X2 whole bar, we will need a NOR gate. So the NOT gate will give us X1 bar. This will give us x1 bar, and finally NOR will give x1 bar plus x2 whole bar. So we will need a total of one half adder, one NOT gate and one NOR gate. And for D, we are not needing any logic gates because D is simply equal to x2. So x2 directly connected to the bit D. So the output is 4 bits A, B, C, D. We have realized the circuit. So we have converted this 2-bit input to a 4-bit output, where output equal to 3 multiplied by x. So this was the simple circuit designing that was done for this question. Thank you. Please like and share the video and subscribe the channel.